Okay. Good. Good now. Okay, my name is Lucas Pratama from Marine Engineering Department, and I'm here to apply candidate lecture assistant for mechanical physics batch 25 and 26. So I'm here with my friends. So would you like to introduce your name, please?
Yes, my full name is Orman Gurbanlı. You can call me Orman.
Do you already apply the university?
Yes, I have applied to Riga Technical University in Latvia.
Okay, that's very good. So I'm here to teaching you about this problem. So basically, you should already answer for the correlation or substitute. So I just give you what do we have here, what we are using for this formula for solving this problem. So okay, so I can start for the questions. So you can see I put the where. So we have the mass first mass is 15 kilograms, and the second mass is sorry. M1, first mass is 15 kilograms, second mass is 5 kilograms, and the angular motions is 37 degrees, and the frictions have, not the friction, but mu k, mu k is 0.4, and mu s is 0.2. This is all that we got. So we have to determine the F and the T. So we basically are using um first law Newton, which has sigma F and zero, sigma F equals zero, and this is for the first law, and the second law is sigma F equals mass times acceleration. So, do you know how to make differences about using first and second hormone?
Yes, I know. The first law has doesn't have this doesn't have like the acceleration, right? But the second one has. Right?
Yeah, okay. That's I think this is simple how to differences between these two laws for Newton. So, okay. So, what do we know is first we have to find the T, the tension. So the question is telling about the right block will move right. So we just move this. So this is a tension. This is not opposite directions. So it'll be
Yeah.
plus. And this for analyzing it will be Wy. So m2g cos theta. This is a normal force. And to the right side is for x coordinate is wx, which has m2g sin theta. Okay. So because there's no acceleration, so we think is the slope of the friction will be up there, going there with an arrow. So the friction we are using the friction kinetic, which is the mu k times m or normal force. So we're just gonna do for the tensions. The tension is mg or t minus mg 0. So t, the mass is we are using m1 force because it's like
Mhm.
the weight of this. We're using the m1. So the 15 times 10, it should be 115 Newton. Okay. So that's for the A. That's for the tension. The tension, it can be used A and B. So it's the same. So, okay, let's take a look for this. The sigma F times zero. We're using first law because we do we do not have the accelerations. So this is the normal force formula, the normal force formula minus T minus W x sin 37 degrees and the mu kinetics and n, the normal forces equals 0. So so um for the sigma forces and analyzing, we have this formula. So for after I'm analyzing for all of these forces, so we do have the friction K, normal force, and Wx, and the friction kinetic. Because why? Because why I'm using the friction kinetic, because there's no accelerations. So then this is for the answer. And B is basically it's the same like the NA, but the right block, we just focus for the right block because this is moved to the left, so it means opposite, opposite,
Opposite.
opposite. So the friction will be have the plus for the frictions. Okay. So it's we do the same, like we still have the force law, so normal force times normal force minus tension minus Wx minus mu k mu kinetics or I'm sorry, is a friction kinetics equals 0. So if we do elaborate for the formula, it will be the I'm sorry, this will be plus F cost is the normal force formula until we got 150, and Wx is basically mg cos theta, and I'm sorry, it's sin theta. So yeah, this friction K is mu K times normal force equals 0. So So see, you can look now for this calculation. So far, become like that. So for the end, at the end, we have forces. So okay, for the number C, it's a difference between A and B for the tangent. So, but it basically the same for the sigma F for analyzing the object. So C is T because they are have acceleration, so we are using the acceleration, so m1 times g plus a m1 m1 is 15 kilograms, 10 times 0 0.5, it should be 15 times 0 0.5 equals 0 157.5 Newton. So this is all for the tension for the C. Why I do the plus acceleration? Because
Yeah,
not both
because
side. Okay. I
Mhm.
think you already understand. So for the number C is the same. Like we do have the Newton. I mean like the normal force,
Mhm.
the tension, the Wx, and the frictions. This is the friction of the static. So in other hand, because we are using second law of the Newton, so it will be sigma F equals mass times acceleration. But the acceleration in here is opposite. I mean like it's not opposite. So we just on the plus in acceleration in here. So it not will be the minus. it should be plus or positive. So that's how to analyzing and calculations. So we'll begin for the D. So C and D is different because the D is about to the left side, which means it's the opposite of
Oh,
the direction. So
okay.
D, the tension equals M1 times G minus A, 15 kilograms, 10 minus 0.5, it's 15, 9.5. It should be 147.5 if I'm not mistaken. Okay then. So D is basically the same, like we are using sigma F equals ma because they are the accelerations. So then F cos is normal force minus tension.
Mhm.
Oh, this tension is 142. I'm sorry.
Mhm. Yeah.
It's not 7, just 142. So normal force minus tension minus um Wx plus friction static or M2 times minus A because this is opposite direction.
Mhm.
So we just substitute to here and substitute again to put a number on
Yeah.
each the formula. So maybe you got the force is 176 and the tension. So for the summary, we got is A is for the tension, we got 150.
Mhm.
The tension is 150 and the force is 350 newtons. And for
Oh,
B, F is 157 and the tension is the same like the A, which is 150. So the
mhm.
second one, we got the 291.2 and the tension is we get 157.5 and the D is where's the D? So the forces we got 176 and the tension we got 142.5 Newton. So I think it's that all for solving this problem and how to analyzing before we start to answer. So far, do you
Yes,
have any
everything.
questions?
You first like look at the end. Thank you. Yeah, everything is good, clear. Yeah, I understood everything. Good.
Yeah, I think you already got so far for this knowledge. Um, uh, thank you for your time to
Thank
con-
you.
be my student.
You,
Okay, thank you, Arman.
we're living. Okay.